reading you Ronnie Kohavi's bio, but he is General Manager for the experimentation platform at Microsoft. This is a team that he founded with the mission to accelerate software innovation through trustworthy experimentation. It's a phrase that I love, Ronnie. So without further more ado, can we call you up?
Thank you, and good morning. So I'm going to take you through what I think is a very fun talk, especially in an audience where we can do some experiments or riddles and questions. So I'll just go and start with the fun story, and then I'm going to back up and tell you what I'll talk about in more details. So this is a story that I love because it really depicts some of the problems that we see in organizations and the fact that some bottom-up ideas don't always end up where they should be. So this is a story from Amazon. Many stories at Amazon can't be told. It's a very, very secretive company, but this one was actually blogged about by one of the people that left, Greg Linden, and so we can talk about it. When you add an item to your shopping cart, I'll take you back 10, 15 years, most of the sites used to just show you the shopping cart. And then Greg Linden had this idea that we could give you recommendation based upon what you just added to the shopping cart. Now, the recommendation technology, I'm sure you're all familiar with. People who bought this book, bought that book, which then got expanded into other items and other variants, already existed at the time. But it was shown on the detail page. So this was a relatively easy thing to do. Use the same algorithm when you add something to the shopping cart. But as with most things, when you look at the idea and you evaluate it, there's a pro and a con. The pro is, obviously, you increase your average basket size. You can sell more items. If the recommendations are useful, people will go and maybe add more things to the cart. And it looked really good. The con was, are we going to distract people from checking out? Instead of getting them to that checkout pipeline, are we going to distract them by suggesting all these items? Is it going to make them forget? Are they going to be late for some meeting and then never check out? And the HIPPO, which is in the title of my talk, and now you understand it, is the highest paid person's opinion, was, we're not doing this. By the way, if you are interested and want to take this to your org, there's a bunch of HIPPOs here on the corner, and you're welcome to take them. Give it to your HIPPO. But the HIPPO at the time, the senior VP at Amazon, said, I want to stop the project. I'm not taking risk on conversion. It's the most important thing. We're not doing this. The nice thing about Amazon, and this is really kudos to Jeff for doing that, is you can always run experiments. I was director of data mining and personalization. I know this is one of those things you can't stop. People are allowed to try things. And that's what was done. I mean, a simple experiment was run. It was widely successful. Indeed, conversion rate did go down, but the average basket went up. Sort of the pros and the cons worked out, but it's the weighting of them that matters. And it was widely successful, and people got shifted to make this better and to build the learning shopping cart, and all sorts of projects started to evolve from this. And this is why I really like this, because it's something that happens a lot in organizations. And most organizations go through this phase, they evaluate ideas, and they get killed by some HIPPO who may or may not be correct. And so one of the themes that I want to share with you is try things out there. And this is the agenda for today. So first of all, I'll tell you about controlled experiments. Really, really simple idea. One slide. Then we'll have some fun. I'm going to put you in the seat of the decision maker. I'll take you through some real examples, real experiments that we ran at Microsoft, and let's see how many of those you can guess right. And then I'll talk, and this will be, sort of the large part of the talk is just to give you real examples. And then I'll go through what I think of as the cultural evolution. Organizations go through these phases. If you learn about Tuckman's model of team formation, the forming, storming, norming, performing, there's sort of something similar here. People think they know what they need to do, then they start to measure, and they're a little bit off. Then they hit something called the Semmelweis reflex, we'll talk about. And then at the end, you get the much more basic understanding of what's going on. Two messages to remember. One, it's hard to assess the values of idea. Really, really hard. We're really bad at it. And I'll give you some interesting statistics. So you get the data, and the data trumps intuition. And then the second point is something that people forget a lot, which is make sure your organization agrees what it's really optimizing for. And that's not an obvious thing to do, because You're not necessarily optimizing for the short term. You're optimizing for some longer term goal. And being able to measure the metrics today that are predictive of that future and getting agreement on it in the org is very, very tough at times. This is not going to be a very technical talk, but there are papers and examples. We've written all the statistics that you need to know about it in papers. This is the website. I've got a few reprints in the corner if you're interested. All the technical stuff is there. I want to have this sort of a more fun talk with some real examples. But first, let me take you through what is a controlled experiment. As I said, really, really simple. You have users coming in, and they're split in this simple example into two groups, the control and the treatment. This is sometimes called an A/B test, controlled experiment, parallel flight. There's multiple names to this. But you split the users into groups. In the simple cases, an A/B test. Control is typically your existing system. This is what you're trying to improve. Treatment is the thing you're trying to test, this new idea. There may be, most examples that I'll take you through here, just one. In reality, we actually try to encourage people to test more variants. And then the interactions that the users have with the system are instrumented. Meaning we collect page views, clicks. Are you interacting with some Flash module, a Silverlight module? So we look at what you're doing. We observe. Now, this is not intrusive. It's not a survey in most cases. Right? We think we should observe you sort of out there in the wild. And then we analyze things at the end. Okay? And our goal is to understand if the metrics coming out at the end are different. Because if these metrics that are coming out at the end are different, and everything else about the users is the same, they're running in parallel. So if it's a good day in the stock market, it's a bad day, if iPad was announced or Windows Mobile 7 was announced, all these things happen to the same population of users. And we're splitting them. Okay, so everything is concurrent. All the external influences are the same. And so you can show that if there is a statistically significant difference in the metrics that you get at the bottom, then that difference was caused, this is the causal trick in all this example, by the change that you've made. Okay, and this is why this controlled experiments are now the standard in the FDA, right, for approving drugs. It's the only way to approve drugs in the state. Whereas if you go back 100 years, there were sort of expert opinions. Now you have to show using controlled experiments that the drug caused the effect that you wanted to measure. Okay, so first of all, there'll always be differences between these. You're just measuring random populations. So the trick is not to just pick the better one, but to run statistical tests to see that it is indeed not due to chance. And this is something often not well estimated by groups. When I first showed the slides a few years ago, somebody says, what do you mean 50-50? You probably haven't run experiments. We run them at 1%. No, we run a lot of experiments on many, many large sites at 50-50. Now, if you've got a really gigantic site like MSN, you can run the experiment on 10% of the population. But for many experiments that we run at Microsoft on reasonably large sites, we're going to split the population 50-50 because that's when you get the most statistical power. Okay, so key point, everybody gets the idea? Our goal is to see that this change caused some difference in the metrics and hopefully a good change in the metric that we're looking after. Okay, so now I'm going to show you some examples that ran at Microsoft. They're all real, all had enough users. You don't have to worry about statistical, did I run this against 100 people? No, these ran against typically hundreds of thousands of people. And we're going to play this game, see how many you can get right. So there's a nice audience. Let's see how the statistics work out, how much better you do than just random. So I'm going to ask everybody to stand up. Yes, please stand up. It's morning. It's going to wake you up. And I'm going to give you three choices in an A/B test. Either A wins and the difference is statistically significant, or A and B are approximately the same, meaning we couldn't detect a statistically significant difference. For most of these, that means it was less than 1%. Or B wins and it's statistically significantly different. Again, I'll point out, there's probably 200 people in the room here. 1/3 will stand up after the first question if you do random. Now, hopefully you're going to do much better, so we're going to see, say, half. Then, 1/9 after the second question. By the third question, it's 1/27 or about 4%. So we'll see if we get something like, 8, 10 people standing up or whether you do a lot better than random. So first example, real estate. If you go to real estate at MSN, there's a Find a House widget. That Find a House widget is the way the site monetizes. Okay, so there's two versions that they want to monetize, either this one or this one. Let me point out some of the differences. This one has city, state, and zip, and a text line. It has radio buttons. And then this is the critical button. As soon as the user pressed this, ka-ching, Microsoft makes money because it's referring to one of our partners this query. Here's another variant. The goal is the same. It's to get people to press the Find Homes button. And this now is arranged in 4 tabs. You can either do city, state here, or you can enter the zip code. It's got this picture of a house. Okay, now, in all these examples, there's this key thing called the OEC, which is what I said. What are you trying to optimize? This one is one of the things I really like. Money is always a good thing to look for optimizing. It's an equalizer. You know you make more money. The money shows up in the bank. It's reliable. It's not some other metric. Some people measure downloads and things, and those don't translate well into money all the time. So this is the criteria. Revenue to Microsoft. Every time somebody clicks on this or this, money comes into the bank. So now think about this example. Raise your right hand if you think A wins. Raise your left hand if you think B wins and statistically significant. And don't raise your hand if you think they're doing about the same. Okay, so now I want you to look in the room and you'll see that, boy, this is not obvious. Some people are raising their right hand, some people are raising their left hand, some people are not raising their hand. Either they're shy or they really think it's no statistically significant difference. Okay. If you did not raise your hand, please sit down. Okay, most people here are active. They think there is a statistically significant difference. If you raise your left hand, please sit down. Ouch. Okay, so you can see a lot of people didn't get this right. Please remain standing if you got this correct. Okay, so what was the result? A was 8.5% better. Now, this is the site whose main monetization is this widget, right? So they just increased their revenue by 8.5%. Not bad. Okay, the actual experiment, by the way, had 6 variants. We didn't just do an A-B. We did an A, B, C, D, E, F, or more variants. What was interesting about this is, that we do these throwdowns. We go to the team and we say, okay, you guys designed these 6 variants. Which one do you think is going to win? Nobody voted for the winning version. There's about 20 people. So it's hard to guess right. Okay, so now let me give you another example. This is the Amazon homepage. The OEC is the click-through rate for search box and popular searches. So here's a search box. This is version A, this is version B. And I'll point out a few of the differences. This has this magnifying glass. This says search. This is a little taller, so the white space where you can type your query is a little bigger. This says popular searches. This does not say popular searches, but both show the same set of popular searches that happen. Okay, so same thing. The OEC is click-through, meaning for the people who saw this page, how many people actually clicked on this button or any of these words that send you what is now called Bing. At the time it was called Windows Live Search. Okay, so raise your right hand if you think A wins. You can enjoy. The people standing up are the ones we want to watch because they're already successful. Raise your left hand if you think B wins. And do not raise your hand if you think they're doing about the same. Okay, so again, you can see some opinions. This is going to be a shocker for you guys. If you raised any hand, please sit down. Okay, so notice at this point you got 2. Are you standing because you voted or because you're some press guy? We got 2 people standing up. Okay, so we're doing in this room a lot worse than random. Right? Should have been 10% standing up. So what's the message? Stop debating. Get the data. By the way, in this example, actually, I'll go back. I'll show that there's 2 differences. One is this branding decision to change to a magnifying glass, and the other one is the big thing. And a lot of people commented that big usually helps. The active words usually help. So there's a conflicting thing in here that was weighted correctly by only 2 people in the audience. And so after this test, we actually did run a test to just check the magnifying glass. The site has changed a little bit. It went to Bing, and we were using the magnifying glass versus the search, and search won by a lot. So it was the case that these 2 were just running against each other and ended up sort of being equal. Actionable words is very, very good. We've discovered this over and over again. You shouldn't say, if you've got a dialog box and it says, are you sure you want to save this? Don't say yes, no. Say save or don't save. Don't say, these are things that now we're beginning to learn what works better. In this case, search wins, and this is what's live on the site. And this was actually very debatable at Microsoft because there's a huge branding behind the magnifying glass. And you'll see this everywhere. Yet, when we ran the experiment, it won, and people made the right decision, which is a hard one because, the branding investment was significant. Okay, last example, Office Online. So there's 2 pages possible for Office Online. This is the site where you can go to look at Office products and things. And what they did is I circled in red, here and here, and in this page here and here, the areas where Microsoft makes money. So this was one of those examples where people said, let's see if we can improve the monetization of this website. And if people click here, here in A, or here, here in B, there is some probability that they will convert to an actual purchase of Office, and Microsoft will make money. Okay, so the OEC here is clicks on revenue-generating links highlighted in red. They were not highlighted in red, of course, for the users. They're highlighted in red for this audience. So now, raise your left hand if you think A wins. Raise your right hand if you think A wins. Raise your left hand if you think B wins. And do not raise your hand if you think they're about the same. Okay, so of the 2 people standing, we see both voting for the left hand, which is B wins. And if you didn't raise your hand, please sit down. Both of them voted. Indeed, if you raise your left hand, please sit down. We got 0 people standing up on 3 questions. Okay, so what happened here? B was 64% worse. That's a lot. And, notice sometimes I say A is better and sometimes I say B is worse. That's because one of them was the control and the other one was the treatment. They had A. They were about to launch B. Okay, so, yeah, I'm usually comfortable asking this question and pointing out that, it's very humbling. We don't get a lot of people standing up, and I've done this a lot. It works really nice when there's a nice, large audience and you can do the statistics. Okay, so now I'm going to take you through something called Twyman's Law. Almost any statistic that appears interesting is a mistake. Okay? If something is really amazing, find the flaw. It ain't happening that way. In that last example that I showed you, we saw the result. We said, nothing goes that bad. And especially if bad, by the way, is easier to get worse. Better is much harder. So, if you find something improves your site by 64%, find your bug. It ain't happening. If you find something hurts your site by 60%, that could be a JavaScript error. Doesn't allow people to check out or something like that. We've seen those. But, this is some examples of things that I've seen Twyman's Law in action. Somebody points out that 5% of people are born on the same day, same year. You look at the data and you find that, this mandatory field, we force people to fill it in. They don't think they should fill it on this game site. They put in 11111. It's the auto-repeat works really good for that. Or 010101. Happens a lot. So another example, if you have an optional drop-down or a mandatory drop-down, don't put the first option alphabetically. I've seen sites where, there's the job list and then you get all these people with astronaut because it starts with A. Think about these things. So this is Twyman's Law, right? When you see lots of astronauts, fix the site. Okay, so now why is the previous example bad? The previous example is bad. And by the way, I'll admit outright, we ran the experiment. We did not see the error up front. The previous example is bad because it measured click-throughs. What they really should have measured is conversion at the end, the actual purchases of Office. But Microsoft's a big org, and they would have to coordinate with the order pipeline, which is a different team. They would have to wait 6 months. Didn't happen. They were like, okay, we're just going to do the red areas and see how many people convert. Normally a reasonable assumption. We thought it was a reasonable assumption to just look at click-throughs from that. But, if you look at that page in hindsight now, who can point out what's flawed with this? Yeah. Okay, so there's 2 different versions of Office, but that's a picture thing. Do you expect that to dramatically change the conversion of Office? Maybe. So this does say, Office Home and Student Edition. So a reasonable idea.
Where's the action button?
Yeah, well, so it's, these red lines, if people click on them. This one has a much cleaner action buttons. Yeah. The size of? The clickable area. That's a difference, actually, a good thing. And many times we find that if you increase the size of the clickable area, more people will click. So that's fine.
On A, you have to click through to get pricing information.
There you go. There you go. This thing has the price on it. That means that when you send somebody to this, when they press this button, they know the cost. You're sending qualified people to the pipeline. This one, on the other hand, doesn't have the price. Now people are clicking through just to see the price. If they go to Amazon, it's a lot cheaper than $149.95. Here, they don't have to click here. They'll go to Amazon and purchase. Right? So the experiment is flawed because we made the assumption that when you click, the conversion rate from a click to through the order pipeline is the same, but it's not. Okay? So this happens a lot. Sometimes we get experiment, the results are too extreme. We're like, this cannot be 64%. And so, we understand in hindsight what happens, and this is why I love this law, because you'll see it a lot. Okay, so message here, hard to assess the values of ideas. At Amazon, half the experiments failed to show improvement. That's a lot. There's a company called QualPro. They published this book called, Breakthrough Business Results with MVT. In the book, they write that they've run 150,000 controlled experiments. Most of these, by the way, are offline. This is, they've done this in the real world with, not necessarily with websites. But 75% of important business decisions and business improvement ideas had no impact or hurt performance. Okay, what happens at Microsoft? Now we've run a lot of experiments. We have some statistics. It's about a third, a third, a third. What does that mean? A third of ideas that we test were statistically significant and improved the metrics they were designed to improve, this OEC. A third of ideas are flat. We're not seeing any improvement. You can launch it. You don't have to launch it. Usually the decision should be do not launch. This is new. Probably you have to teach people how to maintain it and do things. There is some cost to deploying software out there for a long time. And then a third of ideas are negative. Statistically significantly negative. This means that somebody thought this was going to be a great idea enough to spec it and develop it and QA it and get it live in front of real users. And it failed to improve the metrics it was designed to improve. Okay, 2/3 of the time we fail, and that's humbling. Right? And that's one of the key messages that I'm here to share with you is we suck. We just don't know what's going to work, and it's more extreme when you try things where there's not a lot of prior experience, the novel ideas. And by the way, I will say, I'll admit this is sort of the skew that you get when you run an experimentation platform team. People come to you more with things that they don't know what's going to happen. So there is some natural skew to that, but still very, very humbling that this happens so much. Okay, so what's our message out of this? Is first of all, avoid this temptation to try to build optimal features. There's some groups that plan for 6 months and everything is planned and they run and they build it for a year and a half. And then 2 years later, they come out and, they celebrate the launch. This is, by the way, Microsoft's really good at that. You celebrate ship it. You get awards. You don't celebrate if it actually improves the customer experience. It's the fact that we shipped. So that was true, by the way, 20 years ago when you couldn't test this. But now we have the tools to see early on if something is going to work. So first of all, what's the conclusion? You have to experiment often. Thomas said to have a great idea, have lots of them. Second one is a quote I love from How to Do It Wrong Quickly. If you have to kiss a frog to find the prince, find more frogs, kiss them faster and faster. Get your org to experiment more and get the rhythm out there of being able to experiment quickly. Okay, try radical ideas. You may be surprised. It's especially true if it's cheap to implement. So these are the best projects. Something exists out there. We just have to move it or try it. Think about the first example I showed you with a shopping cart. The recommendation engine existed. It was just a matter of plugging in someplace else at the site. And if you're not prepared to be wrong, you'll never come up with anything original. It's a great talk by Sir Karen Robinson in TED 2006. So if you remember one thing from this talk, just remember this slide. The OEC, the overall evaluation criterion. Do you, in your org, understand what you're optimizing for? You will be amazed how many teams come to us and says, I want to run the A/B test. Okay, what's your criteria for success? And then you hear 3 different opinions in the room. So it's not easy. You have to agree on what you're optimizing. And even if you just get that done in the org, and the org is aligned about an OEC, you've achieved something significant. We sort of usually give the guidance that it's about lifetime value, customer lifetime value. Think of that as the metric you're trying to optimize, and see what you can measure today to get that improved. It doesn't have to be a single metric. It could be multiple metrics. We do, however, suggest that you keep them to a small number, and if you can actually put weight on them, that's a good thing. If you can end up with a single number, that's the best. It could be 20% visit returns, repeat visitors. It could be 50% click-through rate. It could be money spent. You can weigh them to give people in the org an idea of what's really important. So when they come up with an idea, they can actually look at this. And I will say this is one of the hardest problems that we face. We've talked to the customer support organization, and they said, okay, the metric that we're going to measure is time on site. And then I asked them a simple question, is more better or worse? And the debate started. Right? Because more time on the site means they're not going to other search engines. They're in our site. But more time on the site means they're not solving their problem. Can we just get them to the right solution, get them out of there so they can do their actual work? So you can see that this is not an obvious thing to do. In Amazon, for example, people say, oh, it's a commerce site. It's so easy, just optimize for money. That's not true. Right? So Amazon weighted dollars in different departments differently. When we were in books, we wanted to get people to buy something out of books because we knew that increases wallet share. Right? So that's an example of something that an organization has to decide. We're going to weigh some dollars in clothing and kitchen and musical instruments higher. Because long term, that's going to drive up wallet share. And then the final thing is some people get confused. We've had one group that just tells us, okay, we're optimizing for X. That's the only metric we're going to look at. No, you have to look at multiple metrics to get that insight. That's one of the problems with controlled experiments. We're going to tell you if A is better than B or B is better than A by X%. We're not going to be able to tell you the why. And so what you need are these secondary metrics and KPIs that help you understand why this is improving. People clicking more, are they clicking on different things, how are they interacting with the sites? All these things are good for diagnostics. Okay, so I've covered a lot of what I wanted to cover. Hopefully you've gotten these key messages. It's hard to assess the values of idea and make sure you agree on what you're optimizing. What I want to spend in the last 10 minutes is basically just talk about the cultural evolution. We've done now experiments with lots of groups at Microsoft. It's sort of a big universe out there. And we see how people go through stages. And sort of, I made this sort of the Tuckman model analogy of 4 stages. So the first thing I want to share is the challenges that we see, and I love this quote. It's difficult to get a man to understand something when his salary depends upon him not understanding it. So we've had people tell us, sorry guys, we're not experimenting. I'm the PM. I'm the program manager. It's my job to select the set of features. You're not going to take that away from me. Our goal is not to take it away from you. Our goal is to have you come up with multiple ideas. And then we'll test them. We'll see which one works. Okay? It's a hard thing to do to come with a lot of innovative ideas. But people are afraid. Admitting that they don't know which one is going to win is hard. That's a cultural shift. We have editors. They tell us we're paid to select great designs. Right? We're paid to select the headlines. How could you even propose that we optimize the order of the headlines on the page? This is an example project that's now live. But it took a huge effort on many, many people to convince the editors that we are going to change their ordering of headlines. Because that's their job. They're the experts. Does this hurt their image and professional standing? As I said before, it's always easier to declare success when you launch. That's it. We're done with the code. It's live. Let's not worry about the people, the customers. We've heard people say it's in our DNA. Why don't we just do the right thing? Well, hopefully I've convinced you that doing the right thing is hard. But let's look at the 4 stages. First one is hubris. The org knows what it needs to do and it's sure of it. Forget the thing. I know what we need to do. I love this story. The problem with these stories is I can't tell too many negative stories about Microsoft. So I picked stories from the 19th century. It's a true story from 1849. I think the best example of hubris. So cholera time. Jon Snow goes around, claims that cholera was caused by polluted water. Doesn't agree with most of the people out there. They claim it's due to what are called miasmas or bad air. That's what's causing cholera. There's one guy, landlord, he lives in one city, he has a rental apartments in another city, and tenants complain their water stink. What's more, people are dying. Okay, that hurts the rent, but there's something to be said about, people are dying. The guy doesn't believe them. So he comes to show how much he believes water is fine. He drinks the water. He dies 3 days later. Right? That's hubris. Somebody is so sure he's willing to risk his life. Now, in the softer world, we don't get that a lot, but luckily so. But that's the first stage that you see in organizations. People are sure they know what to do. Let's just execute full speed ahead. Okay, so, controlled experiments give you the idea of being able to understand if your idea is really worthwhile. So what's the second stage? Amazing story about Semmelweis. Doctor works at Vienna Hospital. This is a teaching and research hospital. And there's a disease at the time, which we don't know about today much. I don't know how many people have heard of the name childbirth fever. But childbed fever is just women giving birth and dying right after birth. Horrible disease. Killed 1 million women in Europe. Okay? And so Semmelweis works at the ward, and he's the first guy to measure things. And he says, wow, lots of people are dying, but I think there's a difference between the wards. He measures his ward, 15% of women are dying. 1 in 6 guys, right? Imagine how bad this is. But he's got this other ward, midwives are handling, not the famous doctors, the midwives. They only got 2%. So what do? You try to control the differences, like what is wrong? We probably have too many people in our ward, and it's overloaded because we're doctors, and the air is bad, and that's what kills them. So he controls for that. He controls for birthing position, diet. He goes all the way to laundry because nothing makes sense. There is no difference. Women keep dying in his ward. Then he goes away for 4 months. He works at another hospital. And, is it him? This is hard to admit, by the way, but, so then he comes up with the insight, which, hindsight seems shocking, but these are doctors. This is a teaching hospital. Every morning they teach on cadavers of women that died the night before. Right? So they go and they, open the bodies and they look and investigate. Could they discover symptoms? Could they discover bad things? And he makes this conjecture, which in hindsight, seems crazy. You got to wash your hands before you go and give birth to a woman. And he says, okay, we're going to try different cleaning solutions. And his conjecture, by the way, is that particles, which today are called germs, are being transmitted to healthy patients on the hands of the physicians. Okay? So, by the way, and this is one thing, and again, in controlled experiments that I'll talk about, this is a hypothesis. He doesn't understand what's going on. He doesn't have the understanding of germs, but he makes this hypothesis, and he tries to do something about it. So he experiments with cleansing agents. And he finds that chlorine and lime is really effective. 18% down to 1%. Right? So he institutes this, takes the death rate down from 18% to 1%. Think about it. 6 in 1 are dying versus now 1 in 100. 1 in 6, sorry. Versus 1 in 100. So, pretty good, right? Success? No! Semmelweis reflex kicks in. This is a name that in hindsight we attribute to him. What is that? That's when people don't believe the data. Okay? Disbeliefs. Where are these particles? They can only hide under the finger layers. It's not enough to kill a person. Okay? The guy's fired from the hospital. He goes to Hungary. Does the same thing at the next hospital. Reduces the rate to 0.85%. Okay, his students publish a paper about the success, and the editor writes, we believe this chlorine washing hogwash outlived its usefulness. It's time we no longer are deceived by this theory. Right? He's got the data. Nobody believes him. It gets worse. He suffers from a nervous breakdown. He's put in a mental hospital, and he's killed by the guards. Okay, so now we have a name for this. It's called the Semmelweis reflex. It's the rejection of new knowledge because it contradicts entrenched norms, beliefs, and paradigms. Now, does this happen only in the 1800s? No! 2005, we still haven't learned to wash your hands. Inadequate hand washing is the prime contributors to 2 million healthcare-associated infections and 90,000 deaths annually in the U.S. Right? Come on, hands before talking to people. Right? Semmelweis reflex. And it happens a lot in organizations. It's sad. Now, this is, lucky, again, we're in software. We don't kill people. We don't have these nervous breakdowns. He, by the way, wrote that he felt responsible for the deaths of many, many women. I mean, he was literally, blaming himself for this. Okay, so what's the stage 4? That's the fundamental understanding. At some point, enough people see that there's value to this chlorine bleach, and they start asking why, and they discover what's going on. And Louis Pasteur showed the presence of strep in the blood of women that had childbed fever, and then they associated it, and antiseptics started to develop. I mean, the world sort of developed from multiple areas in that era. But good news is, in 2008, took 143 years since he dies. There's now a 50-euro coin commemorating Semmelweis. Okay, it's probably more than we'll all get, but hopefully we won't suffer from this reflex issue. Okay, so let me summarize. So there's this evolution about, you go from hubris, you start to measure, you start to control, you understand things, you get some insight. Hopefully you can stop this Semmelweis reflex. It happens all the time. We've worked with groups, we showed them results. It's impossible. They're like, no, this can't be true. My idea has to work. The data's wrong. Do an audit. And then hopefully you get to this better understanding of what's going on. Okay, last slide. So first of all, remember this lovely phrase, the less the data, the stronger the opinions. Always in meetings. There's no data, everybody fights. You got to start to get data, people understand that this has some value. So it's hard to assess the values of ideas. Listen to your customers. When you launch a feature, see how people react to it in the real world. Get the data by experimenting because it trumps our intuition. Get the HIPPO out there to work with the data. Lots of people have ideas, but get it out there. And again, if you want some hippos, they're available here. This is a fun, true statement. Hippos kill more humans than any other non-human mammal. Really? But don't let the hippo in your org kill your ideas. Make sure you agree on what the OEC is. What are you really optimizing? Do the statistics. I haven't talked about it, but it's easy to get this wrong. So there's an article. You can get the reprints here on the web. The statistics are really easy. This is 101. T-tests. Good enough for most of the stuff that we have here. And then just remember, getting a number is easy. Getting a right number you can trust is much harder. I've seen so many incorrect reports out there. They analyze the data, and they have 3 digits of precision, but they get the significant digit wrong. So you got to work. Be careful. This is the area that needs QA. And then experiment offer. You triple your experiment rate, you triple your success and failure rate, but it's really only the successes that you end up launching. So you'll have given the user a better experience. Accelerate innovation by lowering the cost. That's what we're trying to do at Microsoft. We're building a platform that anybody can use so that we can accelerate innovation at Microsoft and make data-driven decisions. Thank you.